Welcome to IIT Foundation Series. Today we will solve a few problem sums based on exponents and rationalization, which are of level 3. So let's get started. This is our first problem sum and we need to find the value of a to the power 1 by a. So what we will do first is we will assume that this a to the power 1 by a, which is equal to b to the power 1 by b, and again which is equal to c to the power 1 by c, that is equal to some constant value which is k. So we can say a to the power 1 by a is equal to k, and separately we can say b to the power 1 by b is equal to k, and similarly c to the power 1 by c is also equal to k. So from here, can't we write that a is equal to k to the power a? We can, right? Now b will be then equal to k to the power b, and likewise we can say, or we can write that c will be k to the power c, and there is one more condition that we will use now. So what we can do next is, since we have found that a is equal to k to the power a as per our assumption, so in place of a, now we will be writing k to the power a and then to the power bc. Now in place of b we can write k to the power b, and then we have power ac, and in place of c, k to the power c, and then power ab, and that is equal to 7 to 9. So we can say that k to the power a and to the power bc, so this power, these two powers will be multiplied with each other, that we know, right? So it will be k to the power abc, and that will be equal to 7 to 9. So we can say 3 k to the power abc is equal to 7 to 9, and that means we can say only k to the power abc will be how much? It will be 7 to 9 divided by 3, and that will be 243. And what we need to find is a to the power 1 by a, and a to the power 1 by a that we assumed as k. So in place of k we can write 1 by a and then whole to the power abc, and 243, it is actually 3 to the power 5, or we can say 243 will be multiplication of 5 3. So now it can be written as a to the power bc, and that will be equal to 3 to the power 5. Now in this equation, if we equate the base and the power or exponent separately, then we can conclude that a will be equal to 3 and bc will be equal to 5, and what we need to find is a to the power 1 by a. So that means that will be equal to 3 to the power 1 by 3. Now in the next question we need to prove that root 5 minus root 3 is an irrational number, and we will prove this by using two methods. So in the first method, what we will do is we will assume that root 5 minus root 3 is a rational number, and that is equal to x. Now what we will do, we will take square values of both the sides. So on the left side, if we apply that, then it will be a minus b whole square, that identity. So it will be a square minus 2ab plus b square. A square means it will be 5, and then minus 2ab, and then plus b square, so it will be 3, and from the right side it will be x square. So further we can say that it will be 8 minus 2 root over 15, and that will be equal to x square. Now what we will do is we will take minus 2 root 15 on the other side, so that will become plus 2 root 15. Now x square that we will take on the left side, so it will become 8 minus x square, and on the other side it will be 2 root 15. So now if we divide by 2, it will be, now 8 and 2 we know they are rational numbers, x that we assumed as rational number. So what we are getting on the left side of this equation, that will be a rational number. But if we look at the right side, on the other side, then we have root 15, and that we obtained by multiplying root 5 and root 3. Root 5, root 3, they individually are irrational numbers, and when we multiply them and when we get root 15, that is also an irrational number. That means in this equation on the left side we have a rational number, and on the right side in the same equation we have an irrational number. So this contradicts each other. That means root 15, this is an irrational number, this cannot be a rational number. And if we look at the other side, we have x, which we assumed as rational number, but 8 and 2, they two are rational numbers. So to be this thing that we have on the left side, if we want this to be an irrational number which will be equal to root 15, then x has to be irrational, otherwise it is not possible. That means our assumption where we assumed x as a rational number, this actually was not true. X has to be an irrational number. And what is x? Root 5 minus root 3. Now this method, if it doesn't satisfy you, then we have another method. There also we will assume that root 5 minus root 3, it is actually a rational number, and we will see whether again it contradicts our assumption or not. Now root 5 minus root 3 we have assumed as a by b. A by b, we know that is the format of a rational number where a and b are integers, b is not equal to 0, and a by b, this is in its simplest form. That means between a and b there is no common factor other than 1. That means a and b are co-primes. Now minus root 3, this if we take on the other side, then we can write this way, that a by b plus root 3, that will be equal to root 5. And again, if we take square value of both the sides of this equation, then from the left side it will be a square divided by b square, right? And it will be 2ab from from the same identity, 2a by b, which itself we took as a, or if we take that as x plus y whole square, then x square plus 2xy plus y square. So it is 2 and x, a by b itself is x, and then y is what? Root 3, and then y square, that means this will be 3, and on the other side it will be only 5. Now what we have done here is we have taken 3 and a square by b square, these terms on the other side. So 5 minus 3 minus a square minus b square, and we have kept this term where we have this root 3 on the left side. So if we simplify further, then it will be 2 minus a square by b square, and on the right side we will have 2a root 3 divided by b, and if we simplify further, then we will get, so finally what we are having in this equation is, on the left side we have 2b square minus a square, and in the denominator we have 2ab, and on the other side we have root 3. Now a by b we assume that as rational number, or root 5 minus root 3 we assumed as a rational number, and that was a by b. So a, b both are integers as per our assumption. So 2b square minus a square divided by 2ab, since a and b both are integers and 2 is also an integer, so this whole form that we have on the left side, that will give us a rational number. But on the other side we have root 3, and we know root 3 is an irrational number. So again these two are contradicting each other. That means our assumption was not correct. So root 5 minus root 3, that is not actually a rational number, that has to be an irrational number. So this is how we solve or we justify this type of problem sum. Now we will move on to the next problem sum, where that is in front of you, and now we will simplify that. So in place of a, we will put this value that is given, and that we will do for other two terms as well. So it can be further this way, that x will be, or x to the power q minus r, we have one term, followed by these terms, y to the power p minus 1, then q minus r, and then we have other terms. So now if we focus on x only, then for the first term we have this power q minus r, and for the second term, which is actually multiplied with the first x, so its power is r minus p, so that power will be added. And then if we focus on the third, or if we consider the third x, then its power, which is p minus q, then that will be also added. And then we have y. Now we will simplify their power, so plus p minus p will cancel each other, plus r minus r plus q minus q. So it will be 1 multiplied by 1, that means final answer will be 1. Now the next problem sum, we have a problem based on rationalization. Now what we will do is we will multiply every term by its rationalization factor. So for the first term, the rationalization factor will be what? It will be 3 plus root 8. And in the denominator, we will have 3 minus root 8 multiplied by 3 plus root 8. That we will apply for all other terms in this expression. So if we simplify further, then from the first term, we will have 3 plus root 8, and in the denominator we will have 3 square means 9 minus 8. 9 minus 8, it will be 1. So here plus 8 minus 8 will cancel each other, plus 7 minus 7, plus 6 minus 6, plus 5 minus 5. And finally in that expression, what will remain is 3 plus 2, and that will be equal to 5. Now in the next problem sum, again this is a sum of rationalization. So what we can do is, first we will rewrite that expression. So the first term was root 10, here it is root 10. Second term root 20 can be written as root over 2 multiplied by 10. That means root 2 multiplied by root 10. So here root 2 is an irrational number, root 10 is also an irrational number, but in the problem statement we have only root 5 and root 10, those values are given, but the value of root 2 is not given, and so we will assume that root value of root 2 we don't know. So we have to simplify this problem sum based on only the values that are given for root 5 and root 10. So another way to represent root 20 is we can write this way, 4 multiplied by 5. So in that case what will happen is root 4. Root 4, when it will come out of the square root, then it will be 2 and then it will be root 5. So that way also we can write. Similarly, root 40 can be written as 4 multiplied by 10 as well as 8 multiplied by 5. In that case, root 5, that value is known to us, but what about root 8? Root 8, again it will be 2 root 2. So root 2 is again irrational number whose value is not known to us. So we will skip that format, or we will not represent that way. Rather, we will choose representing this way, 4 multiplied by 10. So what will happen is root 4, again we can write this way 2, and then it will be root 10, and then here we will have root 5, and again root 80. Root 80, again we can write this way, 8 multiplied by 10. In that case root 10, that value is known to us, that is given. But what about root 8? That will be 2 root 2 finally. So root 2, again the same case, root 2 is not known to us. So another way of representing root 80 is 16 multiplied by 5. And why? Because root 16, when it will come out of square root, then it will be an integer, that will be 4. And root 5, though it is an irrational, but that value is given, that is known. So finally it can be represented this way, 4 root 5. So if we simplify further, then it can be written as, so further this 3 we can take as a common factor, and that 3 will be, when 15 will be divided by that 3, so in the numerator we will have 5, and in the denominator we will have root 10 minus root 5. And if we rationalize this, then in the numerator it will be 5 multiplied by root 10 plus 5, and in the denominator it will be root 10 minus 5, and then that will be multiplied by root 10 plus 5. So again we will apply that identity, a square minus b square. So in the numerator it will be 5 root 10 plus 5, and in the denominator it will be 10 minus 5, which is a square minus b square. So that way we will have 5 only, and this 5 and that 5 will cancel each other. So finally it will be root 10 plus root 5. So finally it will be 5.398. This was the last problem sum of this class. I hope this class was helpful for you. You have understood the concept. In the next class, I will come with a few more problem sums on another topic. Till then, stay safe and stay healthy. Thank you.